This video is lecture 5.5 and it is over the greatest common factor and something we call factor by grouping. So we just saw how to multiply polynomials. When we factor polynomials, we undo multiplication. Okay, so when we factor polynomials, we're going to be reversing multiplication. That means our answers should be something times something else. We should end up with two factors of a product. Okay, so when after we've multiplied, that is the product. Factors are the pre-multiplication. So the first method we're going to learn is the greatest common factor, or GCF. Okay, so let's look at this with regular numbers. Let's say we needed to find the GCF of 35 and 50. Okay, so this is the product. I need to find the factors. Okay, and I really don't need to include 1 because 1 is always going to be a factor. So unless I'm looking at something at times 7, okay, like I can only factor 7 to be 1 and 7. For 35, I have factors other than 1 and 35. Okay, that would be 7 and 5. And for 50, I have 5 times 10. Technically here I can keep going because 10 is also factorable. That is the same thing as 5 times 2. So here I'm looking at 5 times 5 times 2. Then we identify the greatest common factor. Okay, so what is common to both numbers? I have 1 5 here, and because I only have 1 5 here, I can only highlight 1 5 over here. Okay, they each have one of them. So my GCF of 35 and 50 is 5. Okay, we find what is common to both terms. Here I'm going to say all terms. So for example, we can find the GCF between two monomials. Let's say I want the GCF of 20x squared and 32x cubed. Okay, these are both monomials. When we're addressing these types of questions, we want to look at the factors of the coefficients and find what is common to both of those. And then we look at the variables that are involved. And generally, the easiest thing to remember is that we're looking for the smallest number of variables. Okay, so here I have x squared. I also have an x squared over here, but it's being multiplied to another x. Okay, so we can rewrite these two terms to show all of those factors. So if I have 20x squared, 20 is the same as 4 times 5, but 4 is the same as 2 times 2. So this is the same as 2 times 2 times 5. Okay, and I'm going to go ahead and write my x squared here because it's helpful when we're identifying the GCF. Okay, so 32x cubed, well, I know that 2 to the 5th power is 32. So over here I'm looking at 2 times 2 times 2 times 2 times 2. And then I have an x squared being multiplied to x. So to highlight my GCF, I have 2 here, 2 2's here, and I have 2 2's here. So that needs to be in my GCF. I also have an x squared here and an x squared here. Okay, so the GCF of 20x squared and 32x cubed is equal to 2 times 2, which is 4, times x squared. So we really want to talk about factoring a GCF from a polynomial that has more than one term. Okay, so binomials, trinomials, and anything higher than that we don't really identify, we just call them polynomials. Okay, so for example, let's look at 8x squared plus 4. Okay, so if I'm looking for a GCF here, I have x squared in my first term, but I don't have it in my second. Okay, so the variable is not going to be involved in my GCF. Here, the greatest common factor between 8 and 4 is 4. Okay, so 8 is 2 times 4, so let's write it that way, times x squared, plus 4 is the same thing as 4 times 1. And I'm going to write times 1 here because when we factor out this GCF, I need to be able to identify what is remaining after I take it away. So my GCF here is going to be 4. I need to pull it out of both terms. So when we pull out the GCF, we write it in front of a set of parentheses, and what's inside the parentheses is everything in each term that was not my GCF. So in my first term, I'm looking at 2x squared plus, that plus sign needs to stay, 1. Okay, so this would be my solution. If I wanted to check that what I did was correct, I would take my GCF and I would distribute it back into the set of parentheses. So 4 times 2x squared, that gives me 8x squared. And then 4 times 1 gives me plus 4. I end up with what I started with, so I know my work here is correct. My solution is valid. Let's look at something with 3 terms. Let's say I want to factor the GCF from the polynomial 6x squared minus 3x cubed plus 12x to the 4th. Okay, so each of my terms has the variable x. So I look for the smallest exponent here, that's 2, and x squared is going to be part of my GCF because it's inside all of these. 6, 3, and 12 also have a GCF, and that is 3. 6 is 2 times 3, 3 is 1 times 3, and 12 is 3 times 4. Okay, so let's rewrite this so we can see our GCF. So this is 2 times 3 x squared minus 1 times 3 x squared times x plus 4 times 3 times x squared times x squared. Okay, x squared times x squared means I add up my exponents. 2 plus 2 is 4. So be careful when you're factoring your variables because we're using the exponent rules that we've just learned. Now that I have this written out, here I have 3x squared in my first term, I have 3x squared in my second term, and I have 3x squared in my third term. And remember, to factor this out, I'm pulling it out front of a set of parentheses, and inside the parentheses is everything else that's left over. So in my first term, I only have 2 left. Here I have minus 1x, so that's the same as just minus x. And in my last term, I have 4x squared. So this would be my solution. Let's say I was looking at something with multiple variables. Okay, so what about 17x cubed times y squared minus 34x to the fourth power times y squared? Okay, so I need to look for a GCF among my coefficients and for each of my variables. Okay, so 17. I know 34 is 2 times 17, so 17 is going to be part of my GCF. Among my x's, I look for the smallest exponent, so it's going to give me x cubed. And here I have y squared that is in both of them, so y squared is also going to be part of my GCF. Okay, so I'll go ahead and write out the expanded form like we have been just so we can see what we're about to pull. Okay, in my first term, 17 is not factorable any further. X cubed is part of my GCF and y squared is part of my GCF, so I don't have to do any alterations for any of these items. Minus 2 times 17 times x cubed times x times y squared. So here, 17x cubed y squared is my GCF. Here I have 17x cubed and y squared. So I'm going to pull that out front of a set of parentheses. And what's left over is everything that remains. Here, I'm taking the entire term. So what's left over is 1 minus 2x. Okay, so when your GCF is an entire term, a factor of 1 is left over. This is my solution. And I'm going to leave you that comment. If the GCF is an entire term, a factor of 1 is left. Example. Remember here that our instructions are to factor the GCF from the polynomial, and this time we're going to look at 12b cubed plus 4b squared plus 1. Now when we're asked to take a GCF from the polynomial, we have to be able to find the GCF in all three terms. Okay, so looking at these two, I do have a GCF that's not 1. Okay, b squared would be involved and so would 4. However, 4b squared is not part of my last term. And since I want to take a GCF from the entire polynomial, the only thing that's common in all three of my terms here is 1. Okay, so there is no GCF for all three terms. And we say that the polynomial has no common factor other than 1. Okay, so sometimes you can't really pull a GCF out because your GCF is 1, and that's not really helpful. So next, I want to look at a situation where the greatest common factor is inside a set of parentheses. So for example, we're going to be shown some problems that look like this. 2 times x minus 5 plus 3a times x minus 5. So notice we're still looking at what is common to both terms. Here that is x minus 5 and x minus 5. So our GCF is the set of parentheses x minus 5. I'm going to do exactly what I've been doing though. This is common to both terms, so I'm going to pull it out of my polynomial and write it in front of a set of parentheses. And what's left over is what's out front. 2 times 3a, 2 plus 3a. Okay, so to check this, we would take our entire set of parentheses and we would distribute that into the second set. So we'd have 2 times x minus 5 plus 3a times x minus 5. Okay, so this is our solution. Okay, so let's do a problem just like that again. Let's say we're talking about 6 times z plus 5 plus x times z plus 5. Okay, I can still identify my GCF to be the set of parentheses, so I pull that out front of another set of parentheses, and what's inside is what I have out front, 6 plus x. This would be our solution. One more. Let's say I have 4x times y plus 1 half in parentheses plus y plus 1 half. Okay. I still have a GCF that's in parentheses, y plus 1 half, y plus 1 half. But just like before, my GCF here is the entire term. So when I pull my GCF, I'm still going to have a factor of 1 left over. Okay, so remember we have this invisible 1 being multiplied. So now I can pull my GCF out front. That'd be y plus 1 half. Open up a set of parentheses, and inside I have 4x plus 1. Okay, this is my solution. Okay, so notice my solution is always ending up as multiplication. So let's talk about another factor method, and this one we call factor by grouping. So when we're looking at polynomials that have multiple terms, we can arrange them into groups with parentheses and groupings. We can also rearrange the terms. If our terms are not in a good order to factor by grouping, then we can rearrange them. Okay, and we'll see an example like that when we come to it. But for now, let's say that we can arrange polynomials into groupings and look for a greatest common factor in each grouping. Okay, so for example, what if we are given AB minus 6A plus 2B minus 12? Okay, and the instructions for these problems will tell you to factor by grouping, so we know we're going to use this method. Okay, so I could rearrange the terms of this, but let's go ahead and start off with forming our groupings together, and we'll group together the first two and the second two. Then we'll look for a GCF in each one. If we have chosen good groupings, I'm not going to say correct groupings, but good groupings, then what we factor out of each set of parentheses will leave us two sets of parentheses that are the same. Okay, I know that's a lot to take in without seeing it. So first we're going to group everything together. Okay, don't forget this plus sign in the middle of your groupings. Our final answer will be like before. We'll be seeing only multiplication. So now I look for a GCF in each group. So let me make that comment. Arrange in groups. Okay. Look for a GCF. Okay. So my first set of parentheses, my GCF here is A. In my second set of parentheses, here my GCF is 2. So I'm going to pull my GCF out front. So my first term, I'm looking at a times b minus 6 plus 2 times b minus 6. Okay. These are identical inside the parentheses. That's what we're hoping for. Now, for my polynomial, my GCF is a set of parentheses, b minus 6. So just like we saw in the last couple of examples, I can pull my entire set of parentheses out, and I have b minus 6 times a plus 2. Okay, solution is a product. Okay, there's no plus or minus sign in between them. That goes away in our factoring process. Another example, we want to factor by grouping. Let's say we're looking at BC plus 8B minus 3C minus 24. So first, I want to arrange in groupings. So I'm going to go ahead and group my first two together with my second two. Okay. So you notice I have a minus sign in between, and I want to highlight that this is wrong. Okay. The minus sign has to stay with the 3C. Looking at this statement, that means this minus sign could be distributed back into my set of parentheses, and I would have negative 3c. That's still okay. But negative times negative would give me plus 24. So we've actually accidentally changed the problem. Remember I said that plus sign had to be in between them. We want that plus sign. So we want BC plus 8B to be one group plus negative 3c minus 24 in my second group. Now my GCF here is B, and my GCF here is negative 3. Okay, my GCF doesn't have to be a positive number. It can be negative. So if I pull B out of this term, I have B times C plus 8. Here I'm going to pull out a minus 3, so I can write minus 3 times C plus 8. What I have in my parentheses is identical, so my GCF is C plus 8. And pulling that out front, I have C plus 8 times B minus 3. And I'm left with all multiplication, so I know what I did is correct. Okay, so this is my solution. I still want to factor by grouping. So what if we're looking at x cubed plus 15 plus 5x squared plus 3x. Okay, and we've been starting out just grouping our first two together plus our second two terms together. Okay, so I want you to notice something. Here I do have a GCF. My GCF would be the variable with the lowest exponent, x. Here I do not have a GCF. There's nothing I can factor out of here, and so this arrangement isn't very helpful to us. Okay, so notice that I cannot factor the first grouping any further. The GCF between these two numbers is just 1. I need to rearrange the equation. So looking at my original equation, I want to change some numbers around. So I'm going to change places with 15 and 3x. Okay, everything is positive. It's all being added, so I don't need to worry about my minus signs or losing any of my minus signs. But if this was minus 3x, when I moved it, that negative sign would have to travel along with it. Okay, so for now, I'm just going to flip 3x and 15 and see what that gives me. So here I have x cubed plus 15 plus 5x squared plus 3x, and I want to rearrange. So I'm looking at x cubed plus 3x plus 5x squared plus 15. Okay, I could have chosen the middle two numbers to flip. It's the 15 I want to move because that's doesn't have a common factor with x cubed. Both of these do have common factors with x cubed. They both have x. Okay, so I'm just trying something out. It's your choice. You want to rearrange it and then group it. Okay, so now let's group in x cubed plus 3x plus 5x squared plus 15. Okay, so after I take my GCF out, what I have left over in my parentheses I want to be the same. That's how we know that we've selected good groupings. Okay. So my GCF in my first set of parentheses is x. So if I take x out here, here I have x squared left over. Okay, because x times x squared gives me x cubed plus 3 plus here my GCF is 5. Okay, 5 is what is common to both terms, so I have 5 times x squared plus 3. Okay, what's inside my parentheses is identical, so I can factor those out front, and I have x squared plus 3 times x plus 5. This is my solution. Okay, once again, I ended up with multiplication. That's what we're looking for in all of our final answers. So I just tried to flip these two numbers. What if I had flipped 5x squared and 15? Let's try this again. Or x cubed plus 5x squared plus 15 plus 3x. Okay, I do have a GCF here, and now I have a GCF here. So I can group them together. The GCF in my first set of parentheses is x squared. So now I have x squared times x plus 5 plus, here my GCF is 3. So 3 times 5 plus x. Okay. X plus 5 and 5 plus x, they're not written in the same order, but because this is addition, we know that it is commutative, so we can rewrite this as x squared times x plus 5 plus 3 times x plus 5. Now my set of parentheses is identical. This is my GCF currently, so I can pull that out front, and I'm left with x plus 5 times x squared plus 3. This is my final answer. Okay. Notice up here I ended up with x squared plus 3. Here I have x plus 5. Here I have x plus 5. Here I have x squared plus 3. So we want to select good groupings. There may be more than one possible way to factor this by grouping. So once we set up our sets of parentheses, all we're looking for is there a GCF? Okay, in each of my sets. If not, you may have to do some rearranging. Just flip two of the numbers, regroup them, see if that works. If not, you can always rearrange it again. I have one final example. Let's say I have m squared n squared plus m squared minus 2n squared minus 2. So it looks like I can go ahead and group my first two terms together and my second two terms together. So let's start off with that. M squared n squared plus m squared plus negative 2n squared minus 2. So my GCF in my first set of parentheses is m squared. So I have m squared times n squared plus 1. Don't forget, if you pull the entire term, what's left is a factor of 1. Plus, let's say here we only pulled out 2. Okay? Notice I have negative 2 in both of them. But what happens if we only pull out the 2? I would have 2 times negative n squared minus 1. Notice that what's in the parentheses is similar, but one is the exact opposite of the other. Here they're both positive, here they're both negative. Okay, so if you see this, all you have to do in this set is to factor out a negative 1. Technically, you could factor out a negative 1 from here, but since we see the negative 1 over here, let's take it from here. Okay, so I have m squared times n squared plus 1 minus 2 times n squared plus 1. Now what's in my parentheses is identical. This becomes my GCF. I pull this out front and I have n squared plus 1 times m squared minus 2. And this is my solution. Okay. This is the end of lecture 5.5. Okay. There's no Canvas quiz. there is section 5.5 homework on Pearson. Have a good day.